Welcome to the deep dive. Today, we're zeroing in on Intel's brand new Lunar Lake platform. It's looking like a pretty significant development in mobile computing.
Yeah, definitely.
We've had a bunch of sources here, technical breakdowns, performance tests, even a YouTube review looking at a handheld running Lunar Lake. Lots to dig into.
Exactly. And you brought these together because, well, you want to get a really clear picture of what makes Lunar Lake tick.
Right. How it actually performs, day to day.
And critically, how it stacks up against the competition. We're talking ARM, Snapdragon, that whole side of things.
Our goal here is really to pull out the key stuff, those sort of aha moments, without getting lost in, super deep technical jargon.
Yeah, cut through the noise.
You want to know what all the excitement is about, where it shines, maybe where it falls a bit short, and, what it actually means for the future of laptops, portables, all that good stuff.
And some of the initial reports, they're making some pretty bold claims.
Oh, yeah.
Yeah, talk about it being a game changer, even potentially saving by 86 in the mobile space. That's quite a statement.
Wow. Okay, we'll definitely have to unpack that. Let's see if the data actually backs it up.
Let's do it.
Okay, so let's start at the beginning. The core architecture, the design philosophy. What's the big idea behind Lunar Lake?
Well, what's really interesting is that Lunar Lake feels like a very strategic move from Intel. It's their most power-efficient by 86 platform ever.
Yeah, okay.
Clearly designed to go head-to-head with that growing ARM competition, which, let's face it, has been making serious waves in efficiency.
So definitely not just a minor refresh then. The sources mention changes in how the chip itself is built, a chiplet design.
Precisely. They're building on what they started with Meteor Lake, but refining it. You've got a compute tile that's got the CPU cores, the GPU, the NPU for AI stuff.
Right.
And that's built on TSMC's really advanced 3-nanometer process. And 3B specifically.
3 nanometers, wow.
Yeah. And then there's a separate tile, the Platform Controller Hub, or PCH, that handles all the input output connectivity. That's on TSMC's 6-nanometer process.
So 2 main pieces, different manufacturing processes. How do they connect them?
That's where Intel's Foveros 3D packaging comes in.
Yeah.
You can think of it like stacking these different silicon layers vertically, really close together.
Oh.
Allows for super fast connections between them, helps with power thading. And interestingly, it's simpler than Meteor Lake, just 2 main tiles instead of 4.
And stacking them like that gives real advantages.
Oh, absolutely. You get these really fast links inside the package. And crucially, it lets them put large amounts of cache memory, like that 12 MB L3 cache, physically very close to the CPU cores.
Ah, so data gets there faster.
Much faster, reduces latency, speeds things up.
Okay, let's talk cores, the processing power. It's a hybrid design again, P cores and E cores.
Correct. Lunar Lake uses that hybrid approach. You've got the new Lion Cove P cores for performance and Skymont E cores for efficiency. And they're actually physically separated on the chip this time.
Interesting. How many of each?
4 Lion Cove P cores. Each gets its own 2.5 MB L2 cache, and they all share that 12 MB L3 cache we mentioned. Intel's claiming about a 14% IPC uplift instructions per clock over the previous Gen P cores.
14%, that's pretty decent. But I noticed something in the specs. No hyper-threading on the P cores anymore?
That's right, a very deliberate choice. They removed SMT, simultaneous multi-threading, from Lion Cove.
Why do that?
To save chip area, about 15%, they say, and boost power efficiency, maybe 5% better performance per watt. The focus seems to be really maximizing that single-threaded performance, which is key for making things feel responsive.
Okay, makes sense. But it does mean fewer threads overall.
Yep. 4 P cores, 4 E cores means 8 threads total for the CPU. That's the trade-off.
An interesting trade-off, leaning into efficiency. What about those efficiency cores, the Skymont ones?
Also 4 of those. They share 4 MB L2 cache, and they connect directly into the main chip fabric. And Intel's making some pretty huge claims here, too.
Like what?
Like a 68% IPC increase over the previous E cores, and potentially double the performance at just 1/3 the power.
Wow, okay. That's a massive jump for the E cores.
Yeah, if those numbers hold up, it's really significant for efficiency.
Now, one of the really unique things seems to be the memory. It's right there on the processor package.
Exactly. They call it memory on package, or MOP. It's LPDDR5X memory, integrated directly onto the same package as the CPU and GPU tiles.
How much memory are we talking?
Either 16 GB or 32 GB, depending on the specific chip model. And it's fast running at 8,533 megatransfers per second.
And putting it right there has big benefits.
Huge benefits. Over 30% more memory bandwidth compared to Meteor Lake, about 40% less power used just by the memory system, and around 40% lower latency too.
Better than Meteor Lake, okay. How about compared to the competition?
They're saying about 30% lower latency than what's expected from AMD's next-gen Strix Point chips, too. So faster and more power-efficient memory access.
Sounds amazing for speed and battery. But there's a catch, right? You can't upgrade it later.
That's the key trade-off, yeah. Because it's physically part of the processor package, soldered on, it's not user upgradable. What you buy is what you get for the life of the device.
Something to keep in mind when buying.
Definitely. And to help things along even more, there's also an 8 MB system-level cache, or SLC, right next to the memory controller. Kind of like another fast buffer for data.
So a really tightly knit, efficient design overall. How does this all actually feel when you're using it? Everyday stuff.
The reports suggest it feels really responsive. That single-thread performance seems to make common tasks feel very snappy.
Snappy, okay. Good word for it.
Yeah. For general office work, browsing, documents, emails, the Lunar Lake system seemed to match or maybe lag just slightly behind competitors like Snapdragon X Elite or AMD Ryzen, but the gap is tiny, basically unnoticeable in things like PC Mark Office tests.
So for what most people do on a laptop, it's right there.
Pretty much neck and neck. Holds its own very well.
But what about heavier lifting? More demanding workloads?
That's where that 8-thread limit we talked about comes into play.
Ah, right.
For tasks that really hammer lots of cores simultaneously, like, say, video encoding, one source mentioned handbrake transcoding was significantly slower than a desktop Ryzen chip with way more threads. That's expected.
Makes sense.
But for those lighter, bursty tasks, the high boost clocks getting up towards, 4.8 to 5.1 gigahertz, depending on the second card, it performs really well.
Okay, let's switch gears. Battery life. That's always huge for laptops. What are the sources saying here?
This seems to be where Lunar Lake might really knock it out of the park.
Oh, yeah.
Yeah, multiple sources are confirming just exceptional battery life. Lenovo, for instance, reported nearly 24 hours of continuous HD video playback on one of their Core Ultra 7 systems.
24 hours. That's huge.
It is. And they said that was about 5.5 hours longer than an M3 MacBook Pro under the same conditions.
Wow. Okay, that's a serious claim against Apple.
It is. And PC World specifically praised it for having incredibly good Snapdragon-like battery life. That's high praise, given Snapdragon's reputation.
Definitely. Any other benchmarks?
Yep. The PC Mark Office battery test showed a Lunar Lake laptop hitting around 16.5 hours. Compared to about 12 hours for a similar M3 MacBook on the multi-core version of that test. And some OEMs like Acer and Asus are claiming even higher numbers, like 26 to 29 hours for light video playback.
Okay, those numbers sound almost too good to be true sometimes. Real-world usage.
Android Authority tested one and said it easily got through a full 8-hour workday on balance mode, medium screen brightness, with battery left over. So real-world seems strong too.
So the consensus is it's actually beating ARM chips in endurance.
Based on a lot of these initial tests, both corporate and independent, yeah, it seems to be leading the pack right now in quite a few scenarios.
That's a massive win for Intel if it holds up. Any caveats? Does it hold up under heavier use?
That's a good question. Some reports did mention that while it's stellar for light tasks, performance for sustained, like actual work on the go, was described more as just fine. Suggests that if you're really pushing it constantly, you might not hit those absolute peak battery numbers. But the overall efficiency improvement is undeniable.
And a huge part of that must be the low-power design focus you mentioned earlier.
Absolutely. This chip is engineered from the ground up for very low power, aiming for that 10 to 15 watt range, typical in thin and lights.
And it still performs well at those low wattages.
Apparently so. Good single-thread speed, even in fanless tablets or ultra-efficient designs. Intel's claiming something like 50% better performance per watt compared to Meteor Lake at similar power levels.
50%, that's substantial.
Yeah. Leaked benchmarks even showed P-cores hitting 3 to 4 gigahertz while drawing only 10 watts for light stuff. That's really efficient. Better than previous Intel ULV chips.
What about doing more demanding things at low power? Does it just grind to a halt?
It will throttle if you push it really hard, naturally. But the idea is those super efficient SkyMind E-cores can handle background tasks smoothly, so the everyday experience stays decent even when power is constrained. There's even an 8-watt version specifically for passive fanless cooling. And get this, it supposedly outperforms a previous Gen 16-core Core i7 at 15 watts.
An 8-watt chip beating a 15-watt i7.
At 15 watts, yeah. And only slightly slower at 23 watts. Intel's throwing around numbers like up to 3x performance per thread versus Meteor Lake in that 9 to 23 watt range.
Sounds like very clever power management is key.
Totally. The architecture is designed to intelligently shuffle tasks between the P and E cores, even isolating small tasks onto single E cores to save as much power as possible.
Okay, moving on. Compatibility. The age-old x86 versus ARM debate. How does Lunar Lake stack up here?
This is arguably one of Lunar Lake's biggest strengths, because it's x86.
It just works.
Pretty much. It runs a full Windows desktop ecosystem natively.
Yeah.
All your existing Windows apps, drivers, games, they should work right out of the box. No emulation weirdness for most things.
Unlike Windows on ARM sometimes.
Exactly. Snapdragon systems still have compatibility gaps.
Yeah.
The sources point out things like the Google Drive desktop client just not being available natively on Windows on ARM.
Right, I've heard about issues like that.
One source put it bluntly, all apps just work on Intel and AMD machines, but can be hit or miss on Snapdragon.
So, legacy software professional tools?
Should run fine. Adobe Suite, Autodesk stuff. No need for emulation layers like you might need on Snapdragon. Plus, you get access to the whole ecosystem of x86 hardware accessories and immediate support for new Windows features, like Copilot updates.
That's a big plus for professionals, developers,
Oh.
anyone using specific older
It's
tools.
a huge advantage for them, yeah.
Okay, let's talk graphics and gaming. Compatibility matters there too. How's the integrated Xe2 graphics, the ARC 140V?
The reports are actually pretty positive here. It seems to enable smooth enough 3D gaming, at least at modest settings.
Okay, smooth enough is promising for integrated. Any numbers?
One benchmark showed an Asus ZenBook S14 with Lunar Lake scoring way higher in 3D Mark Time Spy-like, more than double compared to a Snapdragon X Elite system.
Double. Wow. What about actual games? Frame rates?
Seeing reports of things like Shadow of the Tomb Raider at 1080p low, hitting around 60 FPS, Cyberpunk 2077, also 1080p low, but using Intel's X86 upscaling, around 65 FPS.
That's actually playable.
Right, and less demanding stuff like Dota 2, easily over 100 FPS. Civ 0, it's around 72 FPS average. The YouTube review is really bullish on it, called the ARC 140V, so competitive it trades blows with AMD's latest Ryzen AI 9 HX370 graphics.
Trading blows with AMD's integrated graphics? That is competitive.
Yeah, they even claimed it was significantly faster than Snapdragon X Elite and a bit faster than that AMD chip in their specific gaming tests.
What about really demanding AAA titles?
Laptop mags testing showed stuff like Doom Eternal and 1080p high. High ran okay, maybe 50-60 feet exploring, but dipped lower in big fights. Helldivers 2 on low was around 35-45 FPS. Elden Ring on low, maybe 25-40 FPS.
So playable, but you gotta manage settings, ray tracing.
The review noted that trying to enable ray tracing in demanding games usually tanks the frame rate too much. Makes sense for integrated graphics.
Still, a big step up. Any word on driver improvements? Intel graphics drivers have had a reputation.
They seem to be actively working on it. Reports suggest recent driver updates have already boosted average FPS by maybe 10% and improved smoothness, the 1% lows, by around 25%.
That's good to hear.
And Intel's leaning into this. Their marketing is basically Snapdragon graphics performance, but without the compatibility headaches.
A clear shot at Qualcomm there. Okay, so decent for light gaming. What about using that GPU for professional work? Creative apps, CAD?
Yeah, the ARC GPU helps there too. Adobe Photoshop benchmarks put it roughly in line with AMD and Snapdragon systems. Good enough for complex filters, effects, that kind of thing.
Video editing.
It has the built-in Media Engine QuickSync, AV1 codec support, so it can offload video encoding from the CPU, which is a big help.
And CAD software.
Xe2 supports the necessary DirectX and OpenGL standards, so things like AutoCAD, SolidWorks should run. Performance likely similar to other entry-level integrated GPUs.
And again, the native x86 compatibility helps here.
Big time. Runs these pro apps natively. No potential emulation or driver issues like you might hit on ARM. It's a definite improvement over just CPU rendering, though obviously not matching a dedicated pro graphics card.
Right. Intel's own numbers showed like a 60% uplift in 3D Mark over their previous iGPU.
Something like that, yeah. A solid generational leap.
You mentioned Snapdragon's compatibility issues with games. Can we dig into those limitations a bit more? Why is it such a problem?
Sure. The core issue is that Qualcomm's Adreno GPUs and their laptop chips just lack native support in a lot of Windows games and even some pro apps.
So developers just haven't optimized for them?
Largely no. PC World put it starkly.
Yeah.
Most games made little or no effort to support Qualcomm's hardware. So what happens is games might refuse to launch because they're missing anti-cheat components compiled for ARM, or they just crash looking for native ARM code that isn't there.
And if they do launch, through emulation.
The performance usually takes a big hit.
Yeah.
Reviewers consistently say modern games just don't run well. Emulated, lots of stuttering, hitching, just not a good experience.
whereas Lunar Lake's Arc GPU.
Runs standard Windows games and graphics APIs natively. No emulation penalty, no fundamental compatibility barrier like that. The Snapdragon GPU often just gets bottlenecked by the software layer, the lack of drivers, or game support.
Makes Intel's Snapdragon without the compatibility concerns line make a lot more sense.
Exactly. The YouTube review we mentioned highlighted loads of games that were basically unplayable on Snapdragon X Elite at 1080p, graphical glitches, textures missing, and a bunch that wouldn't run at all.
Ouch.
And in some cases where both ran, like Civ 6, the Intel Arc graphics were apparently up to 3.5 times faster. Plus, Snapdragon currently lacks hardware support for real-time ray tracing.
Okay, that's a pretty clear advantage for Intel on the gaming graphics compatibility front. Let's talk noise. Thin and lights should ideally be quiet. How's Lunar Lake?
The efficiency really pays off here. Reviews are saying systems are dead silent and cool as a cucumber during everyday use. Those efficient E-cores and the aggressive power management mean the fans just don't need to spin up much unless you're really pushing it hard for a while.
So browsing, watching videos, silent.
Effectively fanless for that kind of stuff, yeah.
Yeah.
Android Authority only heard the fan kick in during sustained heavy loads. And even under moderate load, they tend to stay cooler than higher powered chips, which is just more comfortable.
That's a big quality of life improvement. I saw something about potential fanless cooling tech.
Yeah, Intel's working with a company called Ventiva on something called ICE9 cooling. It's ionic, no moving parts, no fans. They showed it in a Dell Concept laptop.
Ionic cooling, how much power can that handle?
They're saying up to 30 watts commercially, maybe even 100 watts in test systems. So potentially truly silent, powerful, thin and lights in the future. The YouTube review of that MSI Claw handheld also mentioned the fan was whisper quiet, even running Starfield hard.
Very cool. Okay, let's get into the different versions, the SKIs.
All right.
What distinguishes the various Lunar Lake chips?
So far, all the announced ones are U-series, and they all share that same 8-core layout. 4 P-cores, 4 E-cores.
Okay, so what's different?
Mostly clock speeds and the amount of that on-package LPDDR5X memory. The top dog is the Core Ultra 9 288V highest clocks, boosting up to 5.1 gigahertz. Probably some cache tweaks too.
Then below that?
You've got the Ultra 7 series with boosts ranging from 4.8 gigahertz up to 5.0 gigahertz, depending on the specific model number, like 258V versus 268V. Then the Ultra 5 series peaks around 4.7 gigahertz.
Do those clock speed bumps make a big real-world difference?
The benchmarks suggest maybe a 5 to 10% CPU performance difference between the tiers. Like the top Ultra 9 might be 7-9% faster in Cinebench than a mid-range Ultra 7. Noticeable, but maybe not dramatically so for everyday use.
What about the memory differences?
That's another key differentiator. The higher-end models, the Ultra 9, and the higher-numbered Ultra 7s, like the 288V, 268V, 258V, they get 32 GB of that fast 8533 MT's memory.
And the lower ones?
The lower Ultra 7s, like 266V, 256V, and the Ultra 5 seem limited to 16 GB. Having that extra on-package RAM definitely helps with bandwidth and caching for demanding tasks.
So the Ultra 9 is fastest, but the Ultra 7s are probably the sweet spot for most people.
Seems likely, yeah. They'll offer really good performance for most thin and light use cases. The naming convention helps distinguish them, like a 268V and a 256V might share clocks but differ in RAM. Performance scales, but maybe not hugely between adjacent tiers.
We touched on the packaging before, Foveros. Can you maybe elaborate just a bit more on how that chiplet approach actually works? It sounds pretty fundamental to Lunar Lake.
It really is fundamental. Lunar Lake heavily relies on Foveros, Intel's 3D chip stacking. Basically, you have two main active silicon dies.
The compute and the PCH tiles.
Exactly. The compute tile has the CPU cores, GPU, MPU, image processor that's on the TSMC 3-nm process. The platform controller tile handles I/O, security, Thunderbolt, Wi-Fi that's on TSMC 6-nm.
And they're stacked.
They're bonded together, often with a base layer connecting them, using incredibly fine interconnections called through-silicon vias or TSVs. And the base die is also where the LPDDR5X memory sits the memory on package.
So it lets them mix and match the best process tech for each job?
Precisely. Optimize the performance, power, cost. And as we said, it's simpler than Meteor Lake's 4 tiles. The vertical stacking allows for super short signal paths. That's key for getting those big caches close to the cores and keeping memory latency low.
Okay, pulling it all together now. Comparing Lunar Lake directly against its main rival, Snapdragon X Elite, what are the absolute key takeaways from all these sources?
Okay, big picture comparison. First, battery life. Lunar Lake seems to match or even beat Snapdragon in many tests. That closes a gap that was previously seen as a big ARM advantage.
That's huge. What else?
Compatibility. Lunar Lake has a massive advantage being by x86. Software, games, peripherals. It just works more reliably on Windows right now. That's a major differentiator, especially for gaming and pro apps.
And the graphics comparison.
Clear win for Lunar Lake's integrated ARC graphics in most gaming benchmarks we've seen. It's significantly faster than Snapdragon's Adreno X1 in many titles, and supports things like ray tracing, even if performance varies. Snapdragon still struggles with game compatibility and emulation on Windows.
Any comparisons to AMD's latest?
Yeah, the YouTube reviews show the Lunar Lake handheld trading blows with AMD's newer Ryzen AI 9 HX370 chip, sometimes even outperforming the older AMD Z1 Extreme handheld at lower power draws in certain games. Interesting stuff. Performance might even vary depending on the Windows version, like 24H2 potentially favoring AMD in some cases.
And Intel's driver software might have an edge for handhelds.
That's what the reviewer suggested. Things like Intel's Endurance Gaming Mode automatically managing power based on target frame rates and retro scaling for older games were seen as really useful features for that specific handheld use case, maybe better than AMD's current driver options there.
Speaking of handhelds, that YouTube review of the MSI Claw 8 AI Plus gave us a good real-world look. What were the main points from that device analysis?
Right, the Claw 8 AI Plus. Big improvement over the original Meteor Lake Claw, apparently. Good screen, good sticks, decent buttons and speakers.
And quiet.
Remarkably quiet fan, stayed cool. Big plus. On the downside, it was noted as being heavier than the competing Asus ROG LEX, even with a similar battery. Room for improvement there. And the MSI software got some criticism, UI issues, weird integration with Intel drivers sometimes.
And some software positives, too.
Yeah, integrating MSI's quick menu into the main Windows game bar was liked. And while some older game driver issues persist for Intel, that Endurance Gaming Mode was called out as a potential killer feature for handhelds.
How did it actually perform battery and benchmarks?
Battery life estimates were wide, maybe just over 2 hours worst case gaming, up to nearly 12 best case. Performance benchmarks showed it clearly beating the old Claw, and generally trading blows with the AMD handhelds, often showing it edge at lower power settings in specific games.
Okay, let's wrap this up. To summarize everything for you, our listener, who wanted that quick but solid understanding of Lunar Lake, what are the absolute must-know points?
Okay, the essentials. Intel's Lunar Lake is a really compelling step, especially for thin and light laptops. The battery life is genuinely impressive, challenging, and sometimes beating ARM. Performance for everyday stuff is snappy and strong.
And the graphics.
Big leap there. Integrated graphics are now good enough for light gaming, which is new territory for Intel iGPUs. And critically, that x86 architecture means software compatibility is still a major advantage over ARM on Windows.
The packaging and memory are key.
Absolutely. The advanced packaging, memory on package, those are the enablers for its efficiency. It might not top every single multi-core benchmark, but the balance of performance, efficiency, and compatibility is its real strength. The MSI Claw review shows the potential and maybe some rough edges still.
So is it the savior of x86, like some sources hinted?
It definitely revitalizes x86's competitiveness in the ultra-mobile space. That combination of efficiency and compatibility is potent.
And that nugget about the integrated graphics competing with AMD's latest mobile GPUs, that feels significant.
It really is.
Yeah.
That could reshape the whole landscape for laptops without dedicated graphics cards.
So for you listening in and wanting to grasp these tech shifts, understanding Lunar Lake is pretty important. It shows Intel fighting back hard, the whole x86 versus ARM battle heating up again. If you're thinking about a new ultra-portable.
Lunar Lake absolutely needs to be on your radar. Pay close attention as these devices roll out.
Okay, let's leave you with a final thought to chew on. Given these big jumps in graphics and efficiency with Lunar Lake, how might this accelerate things? Could we see the lines blur even more between laptops, tablets, handheld consoles? Are we heading towards devices that can do all of that really well? What totally new ways might we end up using these super portable, powerful machines that maybe we haven't even considered yet?